I've got SPSS open, and the first thing that you might want to do is just compute a correlation between two of your variables. And that's very straightforward. So to do that, all you have to do, and most of what we're going to do is under one of these three things. If you need to make a new variable or recode a variable, right, you go to transform. If you want to make a visualization of some sort, go to chart builder. And when you're getting to the actual numbers of it, like we are today, you go to analyze. So if you want to look at a correlation, guess where you go? You go to correlate. And then if you're just looking at two variables like we're talking about right now, you're going to do what's called a bivariate correlation. So when we talk about correlation, essentially what we're saying is, do these numbers go up together or down together? If you have a correlation of like 1, that's saying it's 100%. That means in one variable, every time it goes up 1, and that other variable, it goes up the same amount. If it goes down, it goes down the same amount. If you had a correlation of -1, that means that they're exactly opposite. So if one variable goes up 1, the other variable goes down 1. Most of our correlations will be somewhere in between, right? So if you have a correlation of like 0.4, that means that as one goes up, the other is also going up, just not as fast, or something like that. Correlations, of course, are not causation, and I really recommend that you check out that Crash Course Statistics overview because it gives you, I think, a really quick, succinct, but very useful and insightful understanding of what correlations are and are not telling us. But these can be really interesting, a good place to start. So we could test a hypothesis. So I'm going to use as my dependent variable this total activities. That was the one where they went through and they said, did they protest, did they donate, did they go to a political meeting, and this is the count of that. So I'm just going to pop that there, and then you can choose something else. So what do you think is correlated with the total number of political activities they took? Well, maybe let's check to see if the total number of issues that they said they were interested in, this is similar, right? They could say that the economy was one of their top issues, that healthcare was one of their top issues, and then that all added up to total issues. So I'm gonna just pop that in there. You can click options and do different things. So we can include means, right, and standard deviations, sort of how the dispersion of the data, or not, doesn't really matter. And then you hit OK. So what do you get here? All right, well, first it shows you the descriptive stats for each of these variables by themselves, right? That the means for this and this, right? And how many responses we have. And then you go down to the correlations. What this correlation is showing you, right, is this is basically a 2x2 table. So if you see total activities, Pearson correlation with total activities, well, that's the same one. So its correlation is a 1, right? It's the same exact data. They do this because if you wanted to do like more variables, they could give you a big table with all these different things. And then you see total activities is correlated at 0.314 with total issues. And it gives you some stars. What this is saying is that that there's something there, that this is a pretty strong correlation. It uses the size of our sample and the size of that correlation to basically give you a statistical judgment call as to this being statistically significant. When you look at the sig here, sig is the p-value. So we've talked about p-values before. And again, a lower p-value will mean that you are having a smaller probability of committing a type 1 error. So remember, p-values are the probability that you're committing a type 1 error. A type 1 error is if you say there's a relationship, but there's not really one in the real world. So what this is saying is that according to these data, you have a pretty small chance of committing that type 1 error. So this is highly statistically significant. So that's how you do a basic correlation.